Hello everyone, welcome to my project report. This is a short brief representation of my work. My topic is about face recognition. Here I will introduce the basic principles and how I achieve it. So, why do we choose face recognition? Here comes the short introduction. Since it is a significantly important technology that is widely applied in modern electronic industry, production, and our daily life. Examples could go as the passport check and anti-terrorism. However, there are many factors in real application disturbing the accuracy and the time cost. So this project will introduce the basic principles of two different algorithms to handle it and make a short comparison based on that. Before we move on, let's come to see the category here. As you can see above, what we focus on is introducing two major algorithms and make comparison. There are many problems in actual use. This could go as the human head positions, like the distance between the man's head with the camera and the direction the man's face looked at. Also, we have to take the obstacles on the head into consideration. Things could go as the earring, glasses, and even the necklace. Finally, we have to consider the time cost, because if you implement such an expensive system, it would be meaningless in actual use. So we can immediately got some short solutions for those problems, and details will be shown later. Solutions could be like the normalization, that is, use fixed position and distance. Also, we require the users to remove their obstacles to decrease the difficulty. Also, for the time cost, we all know it is about the trade-off for the space in exchange for time. So, we will use the URL database. What is URL database? This is a standard human face database which contains 14 individuals, 400 face images. Some face images have facial elements, facial expression, and posture change. In early face recognition research, URL is widely used, and that's the reason we make our choice. So here we come to the pre-processing part. That is the beginning of our procedure to handle the human face recognition, which is called the grayscale. In photography and computing, a grayscale or grayscale digital image is an image in which the value of each pixel is a single sample, that is, it carries only intensity information. Images of this sort, also known as black and white, are composed exclusively of shades of gray, varying from black as the weakest, intensity to white as the strongest. Here I show you the formula of the gray intensity computation. And by that, as now we can represent each pixel in just 1D information. It would be very convenient for us to represent that in the computer. Imagine we have 16 degrees of grayscale. Now we only need 4 bits to represent them in one single pixel. The next thing, as we have mentioned before, is the normalization. That is to fix the man's direction he looked at. As you can see in the picture on the right, the man's head is posed in different ways, especially the direction his eyes look downwards. If we simply capture the part of his face by eliminating the hair and the neck, the result of the face recognition will be unclear. Therefore, we need normalization to make his face front up. What we need to do is the rotation. But how? Here comes to the solution. To rotate the human's face, relying on the eyes in the face. As we can see in the figure on the right, we state the eye distances as ER and EL, and assume human's face to be symmetric, making the eyes in a horizontal height and maintain the relative position rate. After that, draw a vertical line through the picture. Grab the part half of D above and 1.5D below. Here we have 2D times by 2D square area, and this is the rectangle we need, and this is the useful information for all. Now we come to the two major algorithms. The first thing to be introduced is LDA, linear discriminant algorithm. What is it? For multi-class samples classification problems, we use a similar solution. Assume we have double X, which represent n number of samples, and C as class. Right choose the formula for SW and SB, which means the S between classes scatter matrix and the S within classes scatter matrix. Then we can compute the ALDA's criterion function, like the right figure shows. We can also get that introduction here shown on the below. This is all about LDA, and that's all the formulas we will apply in MATLAB. The next thing to be introduced is the PCA, which we call as the principal component analysis. There are four major steps in this algorithm. The first thing is the data pre-processing. Here we will use mean centering calculation. It will calculate the mean of the variables and then subtracts the mean from each variable, which satisfies our main purpose. Next thing, we will find the covariance matrix, which then what we need to do is some simple linear algebra calculation to calculate the eigenvalues and eigenvectors of the covariance. Next, as we have the eigenvalues, select the best key eigenvalues. A typical choice is to reduce the dimension of the data and preserve the variance of 99% of the original data. The variance is considered to be a measure of how much information is included in the feature. This could be written as the formula below, as you can see in the picture. So, okay, here comes to the program demo. Here I will split the whole program demo into 3 sections. Let's first see face detection. That is, we want to draw a rectangle to show us the face we will focus on. It will be run in the MATLAB. Now here is the program. As you can see, first we read the RGB image and change it to grayscale image. Then we use the for loop to compute the grayscale. And after that, we will draw the bounding box. That is what we need to focus on. Here comes to the demo. Okay, 3 figures. The first thing is we change the original picture into the grayscale. You can see only black and white. At that, we will make further improvement to eliminate all the black points or white points of the background to improve our accuracy. Finally, by our algorithm, we will compute the red rectangle and show that in the picture. And this part will be only the part we focus on for human face recognition. Yeah, and this is the first step, as you can see. On the left is the original photo. Yeah, the very famous basketball player. Then on the right, we will have only the small rectangle. That is the data will be sent to the next step. Next step come to the face recognition. That is the core of our program. We will have a database, and for each rectangle we have got from the last step, we will search in the database and compute the difference between them. Then, if the smallest difference is smaller than the threshold, then we will give the found information to tell the user that we have found the same guy. If we have multiple choice, we will choose the one that is most similar. Okay, here comes to the program demo. It is inside this program. And notice the picture is randomly picked. Yeah, okay. On the left we have the target photo, and on the right we will try to search it inside the URL database. Unfortunately, we have found it. So let me show you one more time. Yeah, another photo, and we've successfully found the right guy. Okay. Then here comes to the performance test. On the left, I show you the result for the PCA, and the right is the LDA. Because what we concentrate on is to try to analyze the difference, the pros and cons of the two different algorithms. The script of performance test is written in Java and will be run in Eclipse. First, we will see PCA. Let's go. Notice PCA is a machine learning language. So here we will have some training samples, so the program may be quite slow. Yeah, the first sample finished. Now comes to the next one. Okay, that's enough. Let's quit. So similar things for the LDA, and we will have the picture I have shown you here. Maybe it is not quite obvious from the picture here, so I have made another chart for you. The one on the above is the PCA and the one below is LDA. To compare them, you can see that averagely PCA is better than LDA, but both guys were increasing obviously with more training samples. For LDA, of course, it is less accuracy than the PCA, even with smaller number of samples. But for when it comes to the time cost, it is another story. PCA is a learning algorithm. The time cost of each turn is much longer than LDA. For the LDA, it is not a machine learning language. It simply computes the one-dimension relationship of data, so the time cost is trivial in each turn. The actual reason for that is about the computing amount, because PCA needs to change the input matrix into a vector, so it needs a lot of extra work. So there is no relatively extra preloading work needed to be done in LDA, and that is the pros and cons for the two algorithms. So after that, I have done some related works. That is focusing on how to improve our algorithm. The simplest idea is before recognition procedure. We can make a pre-evaluation of the amount of data to be checked. If it is too big, okay, we split it up and into several small sections. And for each section, we will perform the LDA algorithm to seize the data due to its simpler logic. In next level, we will deal with the same set of data. Since the dataset volume becomes much tighter, PCA's pros accuracy can be applied. And now I have looked over articles, and now the ideal method applied in modern industrial factory is called 2D PCA. So remember, when we are performing the 1D PCA in our project, what we actually do is transfer all 2D matrix data into a linear vector data. That will surely lose some precision and useful information. Fortunately, when we are handling the 2D, things could go as before, and just slightly increased time complexity. So judging from all the things above, we can come to a short conclusion. At first, I learned the basic color transformation rules of image message and get familiar with the formula of RGB and YUV, and that is the base for transferring to grayscale. The next stage, I looked over teaching lessons about the two famous detection algorithms, PCA and LDA, where I finally achieved the performance test work based on the codes on MATLAB and Java. Finally, I made the short comparison between them and tried my best to analyze the reason behind that. The most obvious observation we can get from the research is both algorithms will achieve better accuracy with the increasing number of samples. So, the number of training samples is a significantly important factor determining the algorithm's actual performance. Lastly, I'm very glad to finish this project during this semester. With the procedure pace of this project, I not only learned deeply into machine learning and image processing, where I'm now focused on future work, but also get to know the importance of pattern recognition in relative works, knowing how significant they can be in factory protection, plus how they can be close to our daily life. And finally, I found it is very interesting to dig into this area and try my best to study, research, and make improvements in the future. Okay, that's all. Thank you guys.